All right, beginning 2.3, or polynomial functions, we're going to look at behavior of higher order polynomials. We're going to talk about the difference between even powered and odd powered polynomials. We're going to talk about their degrees, their leading coefficients, the fact that they're smooth and continuous, right? A bunch of things that we're going to get through. So first off, what is a polynomial function? Well, it needs to be of this form. And this is a sub n is just some coefficient, right? The n is a subscript. It's just a number. So if there's 10 terms, you would have a sub 10. Then, or excuse me, a sub 9, because we have a0. So that would make 10. Okay. Then x to the n is going to be what we call our degree. N is the highest power in our polynomial. So you could have x to the 5th and then plus 2x cubed, right? Something like this, maybe plus 5. So the highest power is 5, and that is our degree, okay? The highest exponent. The coefficient of the highest degree term is called the leading coefficient. This is going to tell us about whether our function opens up or opens down. One nice thing about polynomial functions, especially of degree 2, right, quadratics, or higher, they are always smooth and continuous. Now, when you get to calculus, this is going to be really nice, right? When we talk about continuity, right, that's going to be something that's going to be fantastic for taking derivatives and integrating functions. So smooth means that the graph only contains rounded curves and no sharp corners or turns. Later on, you might hear these be called cusps. All right. Continuous means that the domain of all polynomial functions is all real numbers. And we had seen this back when we did our quadratics. So any value of x is allowed to get plugged in. How many turning points does a polynomial have? Well, that depends on, again, the degree n. The number of turning points is n minus 1. We'll come back to that later. Let's talk a little bit more about our leading coefficient. So leading coefficient test. By identifying the leading coefficient, one may determine the end behavior of a graph of a polynomial function. End behavior can be considered as the far left and far right behavior of the graph. So what we mean by that is, as this thing goes on towards negative infinity and towards positive infinity, we're referring to that as the left, far left, and the far right. So we have two options. The degree of the polynomial can be even or it could be odd. If it's even and that leading coefficient, remember a sub n, is positive, the graph of the function rises to the left and rises to the right. That can be seen here in the first image. All right, this one has an even power as its degree. It's to the 4th power. The leading coefficient is positive, right? 2 is greater than 0. That's positive. So that puts us in this situation. And therefore, you see that to the far left and to the far right, this function is rising. If the polynomial is an even and the leading coefficient is now negative, meaning the case we have here, -2 is less than 0, then you'll see that it just falls on both the left and the right. Okay? What if the degree of the polynomial is odd? Okay, well, we have two situations. The first is a positive leading coefficient. Tells us that the function falls to the left and rises to the right. An example of this can be found right here. We have x to the 5th, that is an odd degree. The leading coefficient is 3, which is positive. That's greater than 0. And so you see to the left it falls, and to the right it rises. If the leading coefficient is negative, like the situation to the right here, you'll see that the far left of the function's behavior rises and the far right falls. So in the next couple examples, we're going to go ahead and use this information about the leading coefficients and whether functions are even and odd, and just try to determine what's the behavior to the far left and far right. All right, so for this example, we are looking at the far right and far left behavior of these polynomial functions. To do this, we need to know what is the degree. So we need to locate the variable with the highest exponent. In this case, x to the fourth is the highest. So the degree of the polynomial is 4. That is an even power. Okay. So for even powers, we have two options. We can either have a positive or a negative leading coefficient. So what is the leading coefficient? Well, that is the number attached to the x to the highest degree. So in this case, the leading coefficient is 3. That's greater than 0, or if you'd rather, say positive. And so we have an even degree polynomial with a positive leading coefficient. If we go back to our rules up above, right, even degree, positive coefficient says rises to the left, rises to the right. So I'm going to say far right behavior, or excuse me, I'll do far left first. So far left is rises, and far right is rises. Okay. So that's all we need to do here. The next one, the only reason that this one might be a little confusing is that if you just look at the very first variable to a power, that is not going to tell you the highest degree. So the best thing you can do is put these in what we would call descending order first. So putting this in descending order, we would do negative 2x to the 5th plus x cubed minus 4. So basically descending order just means putting the highest degree first and then the next highest and so on down to if there's a constant, or the lowest degree variable. So this allows us to very easily decide that the degree of our polynomial here is 5. We know that that's odd, and we know that our leading coefficient is negative 2, and that's less than 0. So let's scroll back up. Right, the option said if our degree is odd and the leading coefficient is negative, then this thing rises to the left and falls to the right. So the far left rises and far right falls. And if you wanted just a quick idea of what that might look like, right? If it goes to the origin, it would look like this, something like that, right? So basic S shape. This is not perfect by any means, but that's the idea, that it rises to the left and falls to the right. Okay. All right. Last one here. This one is not written explicitly. And I'm actually not going to multiply this all out because there's a much easier way to do this. Right? If I multiply these two binomials together, this term is going to give me x squared. The other terms are going to give me a single x or no x's at all. So that means that if I get x squared out of that and then ultimately multiply by negative 4x cubed, then the first term here is negative 4x to the fifth. So that's my degree, right? My degree is 5. That's odd. And my leading coefficient is once again negative. So it's the same exact behavior as the one we just did. So far left rises, far, get a kick out of that one, I bet. Far right falls. Okay.